Welcome guys. So we'll be continuing making our differential equation plotter, and today we have to accomplish plotting equations like y prime is equals to some multiple of y time plus some multiple of x. So we have to accomplish this. How are we going to accomplish this? Okay, so what are we going to do? For every x comma y, we are going to calculate y prime, that's the slope, and we are going to draw an arrow, that's the thing. The arrow will be pointing, the slope of arrow will be actually y prime. So first we need a function that draws an arrow. So we need a function draw arrow from n to so let's go initial final of first. Actually, let us not draw an arrow, let's just draw a line just to visualize. And also let me open Brave. So we have opened our things. Now we need a diff equation plotter. So not differentiation plotter, we need a diff equation plotter, and it will take an equation. Now for every y and spacing, y less than height, y plus equals spacing, and just go something like for every x less than width, x less than width and x plus equals spacing, we are going to get the derivative. So const slope, derivative is actually the slope, so slope that is given by the equation at x comma y. Now since we got the slope and we are having x comma y as the starting position, we need a way to get a final position for drawing. So we can consider this line to have an arbitrary length L that we will be choosing on our own. So let's have length also given to this function. So let's go length or L. Okay, so now with a bit of trigonometry we could actually work out what this point should be. So if I consider this to be the axis and this to be our xy point, so this and this is slope, so this is just slope, some angle theta, and we know that tan of theta is actually slope. If I suppose this point to be x dash comma y dash, if I suppose this point to be x dash comma y dash, then by using a bit of trigonometry I could say this is perpendicular upon base. So perpendicular's length divided by base length is tan theta, which will be further equal to, what is the length of perpendicular? So it's y minus y prime. So it's y minus y prime divided by, what is the length of the base? So it's x minus x prime, x prime. Also this point can be anywhere unless until we specify that the slope is being calculated y with respect to origin. So this point can lie on a circle. The x prime y prime thing can lie on a circle unless we specify that x prime and y prime lie on the line x lie on the line passing from x comma y and 0 comma 0. So for that thing we have one more equation, and since this is the line theta, this has the same slope as theta. So we have x prime, or let y prime upon x prime to be tan theta. Tan theta. So we got two equations for ourselves, and we got two variables, so we could solve for x prime and y prime from here. So let's just solve quickly. So after a bit of solving, we get the final position of the arrow to be given by, for the x coordinate it's x minus l divided by square root of 1 plus slope square, and y is given by y minus slope times length divided by square root of 1 plus slope square, not scope, it's slope. So after solving we get these two coordinates for the final point. Okay, so this is the final equals this thing. Okay, so let's quickly just do that. So we have already gotten the slope, so let's calculate it quickly. Ahead is the fast forwarded clip of my struggle. I have to jump back and forth within Gemini and ChatGPT to get things to work. Sometimes it was as simple as a typo, and sometimes it was just not working. So I have to try it many times, and it took me around 1 hour to get things done. You could see the result at the end. The differential equations were super nice. I have to implement a recursive differential equation plotter that takes in a differential equation and a starting point and recursively plots it with some depth. So I will be sharing this code with you, and yeah, so that's it. This thing took way longer than I thought, so I'm just gonna fast forward the next few clips, and I will be directly showing you the result. So guys, this is future me, and I have got this thing to work, and it is really beautiful. You could see all those flows and all those things. So this is a really complex equation that I have plotted. Let me just go and show you. This is the equation that I'm plotting, and man, it is so beautiful. Just look at this. I could actually zoom this in, so let's go something like this. And it's not so beautiful right now, but at this level it's junk, because there is some error. We are not actually super accurately recursing, so there is some error that builds up and the differential equation just blows up. But at this point it seems really beautiful. It's just too fascinating for me. It's just so beautiful. So yeah, I guess that's it for today, and I'll be seeing you in the next video. Do not forget to like and subscribe, and if you want some more mathematics plus coding things, please do tell me. I was thinking to implement a Schwarzschild black hole, so a Schwarzschild solution to Einstein's equation. So yeah, do tell me if you want to see that. So that's it.